Hello and welcome back. In this video, I'm just going to do very quickly go through StatCrunch and see how we can use StatCrunch to do basically all the work for us. So in this question, we said that we got 58 successes, 58 heads out of 100 coin flips, and then the question is, can we claim that the coin is unfair, that the proportion of heads that would be achieved by flipping the coin is not going to be equal to 0.5. So if we come to StatCrunch, there is a calculator for this. So if we come to statistics, and we are testing the proportion of heads. So we come down to proportion statistics, and we have one sample. We flipped a coin 100 times, and that is our one sample. And there are 4 options here with data, with summary, power sample size, and with sample size. So what we want is with summary, because we know the results of our sample. And when we click on this, we can see the number of successes, the number of observations. So the number of successes, we're counting heads. So we had 58 heads in our sample, but we flipped the coin 100 times. So again, so number of observations is going to be the size of the sample. The number of successes is going to be the number of members of the sample that satisfy the conditions we're looking for, in this case heads. So what we want to do is we want to perform a hypothesis test, and so they normally have it set up right away for 0.5, which is exactly what we want. The null hypothesis was that the proportion of heads is going to be equal to 0.5, and the alternative hypothesis, if we look at the drop-down menu, P can either be not equal to 0.5, less than 0.5, or greater than 0.5. In our case, we just wanted to see if the coin was unfair, so it would mean that the probability is not going to be equal to 0.5. And this is all set up. We can output this in the data table, as in it will store it within the rows and columns. We don't need that. I am going to click on the optional graphs, the p-value plot here, and this will create a picture for us to look at. So let's compute, and we'll make this a little bit wider so that we can see. So, so a one sample proportion summary hypothesis test. So the proportion P, we had 58 heads out of 100. So that means that 58% of our coin flips were heads. Our z-score here is 1.6, which, if I come back to how we had worked this out before, it calculates the same z-score. Okay, so that's good, everything matches. And then the p-value, 0.1096, that's the same p-value that we found before. So this calculates everything for you. And to be honest, there wasn't a whole lot of calculation anyway. This was just essentially 2 equations, or 1 equation and then 1 looking up in StatCrunch. And if we click this over arrow, we can see the picture that's going on here. So this is our standard normal distribution. Our z-score is 1.6, which is right here. But because we're looking at a two-tailed distribution, so again, p is not equal to 0.5. So we want both everything that's bigger than 1.6, and if we flip it over, we want everything that's going to be smaller than what we get when we reflect it over, which will be negative 1.6. So the combined area in the red is going to be 0.1096. So this calculates everything for us, and it's quite nice. What I will also do is do the same thing for our first sample, our first question, which was we had 29% of 19 9,136 participants said that they have sleepwalked. So then the question is, can we claim that fewer than 30% of people have sleepwalked? So if we come back to StatCrunch, we want to go to statistics. We are estimating proportions, so we want to do proportion statistics. We only have one sample, and we can summarize the data in the sample. So the number of observations was 19,136 because this is how many people were in the sample. Now we need the number of successes. Note that this is the absolute number of successes, not the percentage of successes. So when we came back, when we checked this before, we took n times p hat. So this is the number of participants times the percentage of people that said that they sleepwalked, and that gave us 5,588 people said that they sleepwalked. So we can punch this into our calculator. And now our hypothesis test changes a little bit. Our null hypothesis, which we found, was going to be p is equal to 0.3. So I'll need to change this. This is going to be 0.3. And our alternative hypothesis, we wanted to see if there were fewer than 90% of people. So our alternative hypothesis is p is less than 0.3. So we'll just click this drop-down menu to see p is less than 0.3. We're not doing a confidence interval, so we won't look at that. And I will click on the p-value plot. This isn't necessary, but it's nice for the picture. And we will click compute. And we see essentially the same values here. So our sample proportion is going to be 0.292. Well, 29.2%, that matches the percent that was told to us in the question. Our z-score, negative 2.41, say round to 0. This is a little different because of rounding. So negative 2.415 as opposed to negative 2.410. However, that third decimal place isn't going to make a whole lot of difference because the p-value, 0.008, is the same thing as the p-value that we found. So this whole thing works out. And again, with the hypothesis, the alternative hypothesis being p is less than 0.3, this is going to be just a single-tailed hypothesis test. So we can see that, yeah, this area down here is going to be 0.008. So this is just a quick glimpse into how to use StatCrunch to find all of the test statistics and p-values for you.